it's extensible to any chain and collateral. So we've expanded it a lot. We're live on 12 different chains or maybe even more. But we're constantly adding new chains, and that's in part to how good this protocol is. There are a lot of issues with it though. There's a lot of user experience type things. So one big thing that a lot of people complain about for a long time now is that it requires a user signature to claim. So that means a user has to send funds, then they have to either keep watching the screen or check back later, and then they have to do something to receive the funds on the other side. If you guys have used other bridges, you've seen that this is actually not the case with a lot of other bridges. A lot of other bridges, you just send it and then you receive the funds at some point later. Another problem is that this protocol requires off-chain coordination. So we have to do a bunch of stuff off-chain to gather all the bids from the routers. And this requires off-chain components. It requires like a messaging service. It requires some things that are kind of like not as trustless as we'd like it to be. A big issue, which our current router operators are constantly going through right now, is that router outages actually harm user experiences. So, like in this case right here, a router will respond to a bid here, but if they go offline at this point and a user puts the funds on chain and a router is not here to submit the receiver side of the transaction, that means the user is just stuck here. And they have to sit there and wait, then they complain to us, and then we end up going to actually poke the router operator and tell them that they need to get online as soon as possible. So this is just an annoying issue altogether. It should just be like set and forget, and outages from the router should not really affect the system at all. Another huge thing here, so I mentioned this briefly, but routers provide liquidity on chain B and they receive payment on chain A. So what is that going to mean if after a long time? That means all the router's funds are going to move from chain B over to chain A. This is okay, but then once the router runs out of funds here, then what do they have to do? They have to take the funds out of here and then move them somehow to here. But if there's no liquidity to move here, then they are essentially stuck as well. And we've had like routers complain about this fact and even like stop supporting some chains in certain cases where they don't want their funds to be stuck. So with that, we get to our hard fork, which is called Amarok. So Amarok is like a mythical wolf-like creature. So we decided to name our hard forks in alphabetical order after imaginary creatures. So A for Amarok. But what problems here do we want to solve? We want to solve the problem that we are unable to directly integrate into smart contracts. So like I said, there are a lot of off-chain components here, which make it impossible. So there's an off-chain component here, and there's also like not an off-chain component, but there's like an EOA requirement here that an end user needs to have a wallet that is able to sign or send a transaction on the receiving side. So what we want is we want to directly integrate into smart contracts. We want smart contracts to be able to call our bridge without having to do anything else and receive the funds and be able to do anything with the funds through smart contracts on the receiving side as well. Also, we want DAOs and protocols to do this as well. So we want the ability to not just have like end users who control wallets to be able to use this protocol. We want DAOs to be able to say, okay, I want to bridge funds from my treasury from this chain to this chain. And we think since we have the most trustless and secure system, DAOs are going to want to use our system to do that. And right now they can't do that. Inability to trust call data. This means we want the ability to provide trusted messaging calls to the destination chain. So we want to be able to essentially call smart contracts cross-chain. We want to solve our reliance on a centralized messaging solution, like I mentioned before, as well as the requirement for router uptime. gas management, all these issues I talked about before. Oh, the gas management thing is a huge one. So routers have to make sure that they're constantly topped up on gas. And if they don't do that, then they'll end up missing auctions, or they'll end up like leaving users stuck with funds. So there have been a lot of cases where we've had to go and bother router operators to actually refill gas as well. Liquidity fragmentation is something that I just mentioned, where you get your funds on a different chain than you uh, send them on, so that leads to your liquidity moving from one chain to another chain. And of course, the high gas cost because of all these on-chain transactions. So these are all the problems that Amarok wants to solve, and of course, we will never compromise on our security. Here's a brief overview of the system. We don't have a very in-depth overview, so I literally threw this together in like 5 minutes. But I will try to go through it as best I can without, getting too much in the weeds here. But a user will submit their funds on chain A. This essentially burns the funds, and it starts a process of sending the funds slowly to chain B, which I will talk about this like slow time delay stuff later. But when the router sees proof of that happening, many routers will essentially send their bids now to a sequencer. So this sequencer is now in charge of collecting all the bids. And the bids that the router sends are able to go directly on chain through a relayer. So the user is able to receive their funds immediately. And I put this little swap icon here because in some cases the router or the funds that the router sends actually do need to be swapped through a stable swap mechanism. So this process all happens really fast, instantly for the user. So the user will basically send funds on one chain, receive funds on the other chain quickly. And this time delayed process is basically a very secure way of sending a message from one chain to another chain. So basically chain B will get proof that these funds on chain A were burned, and it will mint the funds on chain B and get them back to the router. So the router will essentially be reimbursed for the funds it spent through this mechanism of a like slower time delayed process. I hope that makes sense for everyone. That was like a very high level overview, but basically funds get burned on chain A. That proof of burn slowly moves to chain B. In the meantime, a router will come and fulfill a request to send the funds to the user, and will collect the payment later on. And then, so the differences between the Amarok Router LPs are that you now provide liquidity on the destination chain just as before. And this is a huge thing. You receive reimbursement 30 to 60 minutes later on the destination chain. So your liquidity stays on the same chain that you provided in. So theoretically, you could be a liquidity provider for a single chain. You say, all I want to do is keep my liquidity on Evmos, for example, and then you'll send funds on Evmos, receive your funds back on Evmos. And then users pay for relayer completely on the origin chain. So like I mentioned back here, a router is the one who is paying for transaction relays to be done for it here. So that means the router has to put up these funds, and they get reimbursed back by the funds that are transferred across on the chain B. We have changed that in this system, where the users will pay for the funds, the relayer on the origin chain, and the router won't have to do anything. And since there's only one transaction, that's why this whole system works very well, because there's only one on-chain transaction that actually needs to happen. So here, this is the only transaction that the relayer needs to send, is the router actually sending funds to the user. All the rest of these transactions will happen. The router will get their funds back directly through the overall system itself, which is outside of what the router actually needs to do or worry about. You still get the 0.05% flat fee. There's no liquidity fragmentation, no gas management. no penalty for downtime. So this system basically solves all of the problems that we set out we were going to solve back. When we created this first system, we learned a lot from creating like a very highly used bridge system, and we have taken those learnings and applied them to create a brand new system. Yes. So some of the risks of the system right now are that there is a centralized sequencer. So this is basically the main centralized component in our system. What the sequencer does is basically anytime there is this proof of burn happening on chain A, like anybody who's looking at the system from the outside can see that there are going to be funds received at a certain time on chain B. So anyone can be like, oh, I want to go and take this like fee, because there will also be like a fee built into this mechanism. The whole router fee will be given to whoever is able to provide fast liquidity to the user on chain B. So anybody can come and see this and then fulfill it on chain B. So to reduce to eliminate the possibility of this like weird like race situation and having people like try to compete to see who can put the transaction fastest on chain B, we have introduced the concept of a sequencer. So a sequencer collects all the bids from all different routers, and it uses different types of processes to actually choose whose bid gets to fulfill the user's request. There's also some cool things we can do, like we can split bids across multiple routers. We can like fall back. If one fails, we can move on. So overall, the system will be like much more flexible. Oh yeah, another thing, I didn't even mention this, but now routers, so if anybody has seen the current system, basically the maximum transfer size is the capacity of a single router. So if one router has like 10,000 USDC on Evmos, and that's the most of any of the routers, that becomes the most that any user can transfer through the system to Evmos. But now in this case, since transfers can get split like arbitrarily small, you can have like 100 routers complete a single transaction. And so that means you can support like arbitrarily large transfers through the system. Yeah, but that's what the sequencer does. So if that sequencer system goes down, there will be downtime in the system. But luckily, this is just like a very like centralized cloud-based system that we can scale up, monitor, and use very robust Web2 tooling to make this really easy and robust. xApp disconnection. So this is part of the system that we're using, the Nomad system, which is an optimistic. Okay, sorry. I don't know if somebody was trying to talk, but I'll leave some time for questions at the end here also, if you do have questions. But the optimistic system is a way of transferring messages from one chain to another chain. So, if I would urge everyone who's interested in this to like read some of the blog posts that we've put about this. But basically, optimistic systems are very different than most of the other bridging systems, which use proof of stake based mechanisms to verify that funds are transferring from one chain to another chain. They will just give a group of validators like the power to say that this transaction will happen or not. But in this system, basically, we use a fraud proof. So there's a 30-minute or 60-minute time window where a watcher, who is basically a one of n system, so anybody who is watching this transaction to see if everything is okay, if the watcher sees that this is not okay, then they will basically pull the plug and cut the system off right here. So during this time window, they are able to stop a malicious message from propagating from the origin chain to the destination chain. But what does this mean for routers? Because if you remember, the router actually will come in and fulfill this transaction before any of this fraud-proof game has happened. But if this happens, then the router, of course, has already provided their liquidity to the user. User got their funds; they've gone already with their funds. But what does the router do? Router in this case has to wait for the dispute to be resolved. Why is this not a problem? Because we know how to reconstruct the proper like Merkle root and whatever all the data that needs to go into this bundle. So, it's just a matter of time before this can be resolved and the system can work again, and then the router will eventually get their funds. So that's the risk that the router takes, is that their funds could be delayed if this is the case, but that's why they're getting paid for it. Of course, another risk is compromised router private key. So I just wanted to flag this as a possible risk and go over some of the mitigation steps that we've made for it. One thing that we have done is we have set up our smart contracts in a way where the router cannot remove liquidity, the router can only remove liquidity to a designated recipient. So before any of this happens, the router, when they're first registering with the system, will register a recipient that they want to receive the removed liquidity. That means I can say, like, my hardware wallet is the only hard-coded recipient. So now even if I lose my router key, or like my server gets hacked or whatever, my funds are fine, and I'm going to just be able to the malicious user can only remove funds to that hard-coded recipient, which is like my hardware wallet in this case. So we've really mitigated the risk of losing your private keys. Yeah, but that is still a risk, of course. Then a few things. What's next? Of course, our mainnet launch is the thing we're gearing up for. When mainnet, we are in the process. We just launched our testnet. We got a lot of learnings and information from that. We've had like 30,000 transactions happen over the course of just a couple days. We found some issues. We're fixing issues. Lots of you who are running routers now should have seen that your router actually has sent transactions, so that would be good. Launch should happen. I mean, we're saying probably we're going through audits over the next few weeks. So, next few weeks will be basically hardening everything, audits, and then we'll be launching probably, next month after. So router ROI visualizations, this is another huge topic we're working on. The router experience, we want this to be like incredibly great. So we want routers to have full visibility into their ROI, how much they're making, how much, how like what's the status of all their funds at all times. So we're working on some really good like ROI, router monitoring, observability. We really want this to be like a really good process, and we want router feedback and input whenever possible. Another thing, router staking and slashing. So this is one of the use cases for the Connext Next token, is we want routers to have to stake these tokens and get slashed if they misbehave. Right now, since all the routers are very friendly with us, we know they're not going to do anything, but we are going to make this more and more permissionless and decentralized as we go. So we need some kind of crypto economic incentives to guarantee that things are going to perform optimally. And then, just like a little bit about Connext vision. So we want to modularize interoperability. So we've created this thing called the modular interoperability stack. We've broken it up into a couple different things: liquidity, messaging, and transport layers. Connext is providing the liquidity. Messaging, like I mentioned, we use Nomad for the slow messaging capability between chains. There's also a bunch of other messaging systems like within ecosystem itself, like Cosmos, IBC, Polkadot, XMP. I think that's what it's called. So, we will be building essentially the equivalent of like a routing that will route over different messaging protocols as it's needed. And then, of course, off-chain infrastructure is our transport layers. So all our routers, the things that you guys are running, will be, of course, used to basically be the backbone for this entire system. So in a nutshell, that's our vision. That's where we're going. And yes, thank you guys for listening. Happy to stick around and answer any questions if there are any. But for now, I will stop sharing my screen.
Thank you, Rahul. Very interesting speaking. Very interesting. Could you return back to the first slide and show it again? Actually, I started recording from the second slide, so could you comment it a bit again?
This slide?
Yeah, this slide.
Yeah, for sure.
Could you comment it again, once again?
Oh, sorry, you want me to comment it? Okay. Yeah, so the legacy protocol, the way it works in a nutshell is an SDK user will broadcast a request to make a swap. So this is an off-chain system that is taking care of providing this broadcast capability. So when a router receives this broadcast, all the routers will respond with bids, and the SDK will essentially choose what the best bid is. Then the SDK user will submit a locked payload to the sender chain. The router will see this locked payload, and then it will submit its own locked payload to the receiver chain, which contains the funds that the user wants to receive from the bridge. Then when the user sees that the router has locked the funds and they're locked correctly, then it will provide its secret to unlock the funds. So that's what this submit to chain is. That's the fulfill part of it. It will unlock the funds to the user, and then the router will now see that the fulfill event has happened, and now it has the key to basically unlock the funds on the sender side. So it's a very basic, like, atomic lock based mechanism. Yeah, it's very secure. It works well. If you can see, like, some of the con points are, of course, 4 transactions here, auction broadcast bid. This all has to happen through like an off-chain coordination mechanism, and the user has to submit this either signature or transaction to chain.
Thank you very much. Actually, we haven't got any questions in stage chat. Maybe, guys, can you share this presentation? Can you share? Rahul?
Yeah, I would like to know, like, the assets the routers have to provide. These will be like mint and burn assets in all cases.
Yes, that's a good question. That's part of, yeah. So I didn't fully touch on the other part of this, which is like the stable swap mechanism, kind of just because I ran out of time making the presentation here. But basically, yes. So this part of the system is like the mint and burn system. So a user will burn funds on this chain, mint them on this chain, and that will be what reimburses the router. So that means that's also what the router will hold their liquidity in and provide their liquidity in. But then the user, of course, in some cases does not want the mint and burned asset. Like, for example, if you're sending funds to Polygon, you don't want the randomly like bridge minted USDC. So you want the like Polygon POS USDC. So for that, we need a stable swap. So we need to build stable swaps into our system, and we need LPs to be able to provide liquidity in that system, which is a separate type of liquidity provider that is also needed, will be needed on some chains, not all chains, but chains that have a canonical version of the asset already will need these special liquidity providers. But the router will always provide their funds in the minted and burned asset. Actually, I should have made like a diagram of this, because there's a pretty cool way to do this. All you have to do is you will take your funds on the canonical chain, for in most cases will be Ethereum. So you'll take like $1 billion worth of Ethereum. You'll send $100 million through this mint and burn bridge to chain A. You'll send 100 million to chain B. And then once that arrives, basically you will have the minted funds on that chain already. So it's really easy to get the minted funds if you don't have them. You don't have to go through swaps or anything like that.
Cool, that definitely makes sense if I have all my liquidity like on this one chain. But if my liquidity is already distributed, I can use this stable swap also to swap the other way to get the mint and burn asset.
Yes, you can. Like I said, you don't need to. It'd probably be, I mean, you can avoid the fees by just like bridging from the chain itself. We have a way to specify that you want the mint and burn assets instead of the actual like swapped assets. So you just have to specify that, and then you would get the minted assets yourself here.
Sounds good. Is there an example for this already, or because as I saw, the test routers do not use the same approach at the moment?
Yes, at the moment, we are still only using this like mint and burned asset, which does not have the stable swap mechanism behind it. But the next step that we are planning to roll out is this stable swapped asset. So you'll see a better example of like how to provide liquidity, how to get liquidity there, and everything like that. And we'll provide some good like UI tools for it as well.
Nice, thanks.
I have one question about watchers. Could you tell more a bit more about them? So, am I correct? This is like Nomad stuff or not?
Yes, so that is part of the Nomad protocol. The way Nomad approaches the idea of watchers is that the dApps should run the watchers because they're the ones who are basically most concerned about their security. So they want to have the like, you know, the overview of the system to make sure that things are working okay. So we will be running watchers for the system itself. One thing we've talked about doing, and we probably will do, is we will make all the routers watchers themselves. So the routers will basically have the ability to watch and make sure and provide like a huge decentralized network of, you know, watchers who are watching to make sure no fraud occurs.
Yeah, that's a great idea. And also, I have one more question about Redis. Is it correct that Redis will be used like for save that state for mint and burn tokens?
Yeah, so Redis is not used for saving state of mint and burn tokens. So router does use Redis, but router uses Redis just to keep track of the transactions that it has already basically like categorized. So the router is basically watching the chain to like constantly make sure that it is responding to all the requests that come through. So anytime these like burn events happen, the router is keeping track of those, right? So for that, the router is using its Redis cache. So it's just like an easy way to like look up that.
So in that case, if Redis goes down, it will take a bit more time for router to come up and run. That's correct.
Yes,
So he
exactly.
need like to get the state from smart contracts or from blockchain or subgraphs.
Yes, exactly.
Okay,
Exactly
thank you.
right. Yeah. And that's a good point. So yeah, if the Redis cache is not there, then it just has to sync the chain, which might take a long time. And we're already seeing that it takes a long time because there's tens of thousands of transactions. So, you know, we are gonna have some ways to do like a fast sync. It's nice because these routers are not like chain validators, so they don't need to like really sync. They can just start from wherever the latest transaction is, and it doesn't really matter if they like don't respond to the old ones because there's other routers that will respond to the old ones.
Yeah, and so this cache is like the same for all routers, or it's like special for each one. Like,
It's the same for all routers. Oh no, you mean like you mean are they sharing a cache?
Yeah.
No. Each router has its own cache.
Okay. So I'm thinking about like snapshots and other stuff like this. So yeah, thank you.
Yeah. Yeah, like I said, there's not really a need to snapshot. I mean, what you would want to do instead of snapshotting is just like just specify where you what nonce you want to start looking at. So once you specify what nonce you're starting to look at, then you can just like look past that. You don't even need like a snapshot or anything. You just need like a single number essentially to say where to start.
Yeah, that's great.
One question about the bidding of the routers. How do you choose the routers? Is there something the routers can do to like answer quicker or something like that to like get an advantage?
Yeah, that is a great question. We don't want it to be like the first one to answer gets it, because you know that's not the right incentives that we want to incentivize. So what we do is basically we start a timer from the first bid we receive, and then 30 seconds after that we'll look at all the bids and choose one. So how do we choose one? Right now we just choose random, like we literally just do a random sort. Eventually we're planning to put more kind of better things into this, like, you know, we will split transactions by default to try to give fees to as many routers as possible. Also, we're thinking of other ideas, like, you know, some sort of fake waiting situation where routers that have fake can maybe wait things better to actually increase their chances of performing in the auction. But yeah, for right now, it is random. Excellent. Any other questions then? Cool. Well, thank you everyone. That was really good. Please, you know, I hope everyone here is in the router track, and if you're not, please, you know, try to, or would love to see you in there. We are getting to the point of being ready for mainnet soon, so every router, please encourage to like give feedback, tell us how things work, help us to improve the system, tell us what more tooling you'd want, what more observability you'd want, things like that. So yeah, we want to leverage you guys as much as possible.
Thank you, Rahul. We have one additional question in Road to Track channel. Can you explain the relayer again?
Yeah, okay, so the relayer, basically, I mean, okay, so the reason why the relayer exists is because it's not very easy to send transactions to chain through like an automated system, an automated asynchronous system. So if this router is like, you know, if there's thousands of routers sending bids for thousands of transactions to the sequencer, and sequencer is trying to send them all to chain, then it's actually a very difficult process to manage the process of sending transactions to chain in a way where they reliably get to the chain, while managing things like the wallet nonce and stuff like that. So what we've done is we've found that relayer providers like our partner Gelato are very good at this. Their entire business model is based around relaying transactions and sending them to chain. So we've made relayers a very integral part and a core piece of our infrastructure, so that we can make sure that transactions reliably get to chain and users are never like stuck waiting for their transactions to come. They know that they will always get them. I hope that answers the question.
Thank you very much. All is clear. Amazing presentation. Thank you again, Rahul. So guys,
Awesome.
if you have any question, you can ask later. Also, we will share recording of this meeting and presentation. Could we share a presentation, Rahul?
Yes, of course. I will share this now, actually. Yeah, I will share this in the router chat. Also, else once.
Okay. Thank you.
Okay. Thank you, guys.
Thank you.